to all my students. Those who have already done the classes with me, they know it very well. And this problem, 99% faces a problem in this, and this gives a realization, physical realization of this numerical value. The main purpose, I'm not a maths teacher, my job is to make you understand physics in real life. That is maths in real life, sorry. So if you want to explain maths in real life, then I have to explain you something with which you understand much better way. So let me go to a better picture. I'll make a picture here. This is nothing, a polygon like this. So in normal classes I give time to students to answer me, but here of course I cannot wait because there's so many restrictions. A, B, C, D, E, F, G and H. This is a polygon. So you have arrow moving in this direction, all are vectors. So let me name this vector is A here, A bar, this is B bar, this is C bar, D bar, E bar, F bar, E, F, G and H. So these are the vectors we have. Now I ask you to find out addition of all these vectors, resultant. What would be resultant of addition of these vectors? Of course, this vector cannot be directly implemented with parallelogram law. So what do you do in that case? If I make a triangle here, this is a triangle. This is a triangle now whose one side is, I did a mistake, I'm sorry, extremely sorry. The diagram was not so clear, so I did a mistake with my own fault. This is A and C. Suppose that this is your vector A and B. So this is a triangle. This is a triangle. Please note this. I can apply triangular law in this. This is A is one direction, B is another direction. So this is A plus B. Resultant. Triangular law says like this. Two vectors acting in the consecutive direction of a triangle is equal to the resultant that is in opposite direction. So this is opposite direction. Please don't misunderstand. Opposite means not in this direction, opposite in this direction, because if these two vectors proceed in this direction, they will be in same direction. So we can consider these to be opposite direction. So this itself is also a vector. Remember this. A plus B itself is also a vector. Now this vector and C will make another vector here. This vector and C will make another vector here. This is another vector. So I'll consider this to be A plus B plus C. Please try to understand. A plus B for this and C for this. So this resultant is A plus B plus C. Similarly, I can make another vector resultant like this for this triangle, where A plus B plus C is one side and D is another side. So this is my direction of resultant. So this will be A plus B plus C plus D, and this is another vector where I can consider this to be A plus B plus C plus D, this one, plus E, A, B, C, D, E, E. This is my direction. Again you come with this. Here you get the same story. A plus B plus C plus D plus E, this is the one, added to F. This gives you the resultant. Direction will be this. These two are consecutive sides. This is the third side in opposite direction. So this will be A plus B plus C plus D plus E plus F. But problem will be now. Now you will face problem. How? Let me tell you. This is in cyclic order. This have tremendous value. Whatever resultant you get here, this and this are in cyclic order. So you cannot simply consider triangular law with this. If you consider this to be one of the vector, that is, let me write it, A plus B plus C plus D plus E plus F is one vector. This is A plus B plus C plus D. This much is one vector, plus F, will make you this. Here in this triangle, f plus this whole thing plus g will make a vector if I take minus of h. Please try to understand this. This is the most crucial concept. H is this in this direction. H is in this direction. See, H is in this direction. If I take minus of H, then it is in this direction. Minus of H. Then my triangular law is valid. These two are in consecutive direction. The resultant is opposite direction. So if I take minus of H, if I take here minus of H, it is enough to say this. If I consider like this, then I can easily rewrite this. A plus B plus C plus D plus E plus F, plus G. I'll bring this minus H this side, so this becomes H, and that will be equal to 0. That means summation of all the vectors in a polygon are going to be 0. Now, where in practical world we use this? That is very important for you. In a real life situation, you have a car stuck in puddle. In a rainy day, stuck in puddle. You have a car and it is not moving ahead. So what do you do? This is my car. This is my car, suppose, stuck in puddle. We give some brick, some stone here. Then it starts moving. Suppose say, why? This is my wheel. This is my wheel, and these are the pedals. Means very muddy soil, ekdam naram hai, so there is no friction, no reaction, no force given. This wheel is nothing but like a polygon having vectors. When you press accelerator, it is moving like an polygon, like the same polygon. So no velocity, nothing, no resultant will be out. All will be within. Net result will be 0. Now we are pouring some stones, some bricks, something strong, solid there. Then some of the vector will split into 2, and you get resultant of this, and with this the vehicle will move forward. In a ceiling fan, you have same story. If you have ceiling fan, we have 3 wings, and if you have 3 wings, and if you don't give the wings tilted, then we won't get any air cut, because the fan will move without any tilt. There will be power consumption, but resultant will be 0. Hence they make the wings bit tilted. आपने देखा होगा पंखा को थोड़ा घुमा दिया जाता है. The reason is very simple, so that it can give resultant outside. That is what the main summary of my addition of vectors. So this is how you handle addition of vector. So real application of addition of vector comes in real world, and we'll try to discuss some of the numericals after completion of the product. Fine. So this is how we talk about our addition of vector. Thank you very much.